To engineer a Keshe health balancing system, whether it's a localized handheld tool or a massive, fully immersive rig, we have to map the exact construction protocols and plasmatic flow schematics required to drive energy across a biological gap. The entire architecture relies on one single physical mechanism. On the left side, we place a high-pressure emitter block. On the right, we wire in a low-pressure systemic sink. The plasmatic fields flow strictly from high to low pressure, traveling straight across the empty central space, the space where the human body will eventually sit. But before a single wire is connected, there is an absolute baseline rule for the hardware. Every single piece of copper, plastic, or structural material that interacts with this field must be completely nanocoated. If you place untreated matter into the circuit, it acts as an impenetrable physical barrier to these specific fields. The energy stops dead. You must nanocoat the material, turn it black with a diamond-layered structure, so the flow can seamlessly pass straight through it. This design logic scales fractally. The rules governing the smallest millimeter of wire are the exact same rules that dictate the assembly of a 2-meter stationary rig. You master the nanocoating process, and you master the pressure gradient. That is the mandatory foundation before assembling any physical hardware. We start with the smallest, most localized element of the system, the plasmatic pad. The pad's construction is straightforward. Cellulose paper is submerged in a small, sealed bag filled with liquid plasma, like CO2 or fruit GANS. Cellulose paper is chosen explicitly because it naturally acts as a GANS state itself. It doesn't present as raw matter to the field, meaning it causes zero interference with the plasma transferring to the body. For precise directional plasma flow, we step up to the health pen. This schematic reveals the pen's internal architecture: an outer coil, an inner coil, and a central straight wire. To centralize the field, these internal wires must twist together strictly at the front tip. That single convergence point gathers and projects the total energy outward. This architecture establishes a clinical rule: physical direction dictates energy transfer. Point the tip at an imbalance to feed energy, a gravitational effect. Turn the pen around and the field reverses, pulling excess energy out, a magnetic effect. The health pen accurately manipulates fields on a local scale. But to push vectors across a larger regional gap, the system requires an autonomous power engine. We generate that high-pressure plasmatic push using a specific component, the split battery capacitor. Within the broader circuit, this unit functions as the primary field emitter, initiating the entire flow. The cross-section requires a central copper wire with its plastic insulation left intact. Next, that insulated core is wrapped tightly in nanocoated paper. Finally, we apply an outer wrap of thin aluminum foil, or zinc. This foil layer must be nanocoated. Don't use direct flame, it melts instantly. Soak it in hot caustic soda or ash until the surface darkens. Wrapped over this are 5 distinct copper coils, each directionally looped to drive the field forward. This configuration gives the completed unit a definitive electrical polarity. The battery side, where the foil sits, acts as the negative terminal. The exit point of the capacitor acts as the positive terminal. This layered construction guarantees a continuous, autonomous push. But raw pressure is useless without a structured pathway to guide it. We shape that pathway by building the mini-system. This is the first structural assembly capable of driving an automated regional field flow. The setup places 2 opposing Magrav arrays, a magnetic coil with 144 turns, a gravitational coil with 81 turns, mounted on plates 13 centimeters apart. To link these arrays, the wires are not twisted together bare. Instead, you use a plug-and-play connection, sliding the coiled end directly over the straight end of the next. We surround these connections with nano-coated tubing to create plasma tunneling. The energy bypasses the wire surface, firing rapidly down the tube's hollow center. This inner channel drastically increases both the density and velocity of the plasmatic field. We now have a high-velocity stream rocketing out of the capacitor. If that stream doesn't have a low-pressure destination, the entire system stalls. In this diagram, we place a puller at the end, a container of liquid salt water wired to the receiving coil's terminal. When directed energy hits this sink, the salt crystal acts as a hard gradient, violently dispersing the incoming vectors outward. Because the energy is scattered, it cannot gather the momentum to return up the line. This explicitly prevents the plasma from circulating back into a closed, stagnant loop. The emitter pushes, the gap translates, and the salt pulls. The complete mini-system proves you can force a one-way plasmatic wash across a biological gap. To engulf the entire human body, we take those exact same mechanics and scale them up into the large stationary rig. The architecture now requires 3 stacked sets of paired Magrav coils on the left side, mirroring 3 sets on the right. For the structural frame holding these arrays, builders should avoid using nano-coated copper scaffolding. Instead, the preferred material is lightly charred or burned wood. The carbonization of the wood yields a significantly stronger plasmatic interaction with the ambient fields than standard metal supports. When securing components to this frame, standard tape or superglue will block the flow. You use hot glue as it behaves as a non-obstructive GANS that the field easily slides past. This schematic shows the entire system wired strictly in parallel. Every positive terminal links to one main positive trunk, every negative to a negative trunk. This exact logic extends to the hydrodynamic helmet, whose smaller coils integrate seamlessly into those same parallel trunks. For final hardware integration, we wire 3 independent health pens directly into the saltwater polar side. Instead of projecting outward, these pens point back inward, creating localized concentration vectors to pinpoint specific areas inside the massive ambient field. The massive scale and the complex wiring can look intimidating, but when broken down, the large system is simply a fractally scaled mini-system engineered to engulf the entire human physiology. This animation illustrates the fully constructed large system operating as a single fluid entity. Energy leaves the left capacitors, tunnels straight through the parallel lines, washes cleanly across the central biological gap, and gets drawn violently into the right side saline basin. None of this functions without the diamond layer nanocoating. That chemical alteration is the single factor that converts standard electrical copper into a plasmatic conduit. You must establish the pressure differential. Without the outward push of the capacitor and the terminating pull of the dispersed salt, the field stalls and remains entirely static. When introducing liquids into the components, stick exclusively to CO2 GANS for these health-focused rigs, and strictly maintain that parallel wiring architecture across all scaled arrays. Any deviation disrupts the flow consistency. Plasmatic architecture does not tolerate approximations. You adhere meticulously to these physical parameters. By mastering the coatings, the wiring, and the gradients, you transform basic copper coils and saltwater into a highly directed, full-body healing environment.